Hi, and welcome back to the R for Lean Six Sigma YouTube channel. I'm Tom Radna, Lean Six Sigma Master Black Belt and graduate student in Applied Statistics at Penn State University. And this video really is going to serve two purposes. One, it is a companion video actually to my final project for my Stat 497C class, which is the R programming class. And it's also meant for Lean Six Sigma practitioners to show them how R can be used to build web applications to do statistical analysis, and in this case how to do some of the typical steps that would be done during the measure phase of a Lean Six Sigma project. In doing so, I think we will give a brief explanation of how the Shiny R package works to build web applications, and then really to show how the analysis can be done. And the particular application that I've put together will provide the following analysis that are typically done again in the measure phase, including a graphical and statistical summary of a data set of continuous data which is not grouped individual data points. And additionally, it will provide opportunity to show a box plot for that set of data, an individual's control chart to check the stability of the data from the process that the data was collected from, the ability to do capability analysis and provide a lower and upper spec limit, and finally to provide a display of the raw data that's in the vector R data set that's being analyzed. So in order to do the web application, which is really quite simple to do with the R Shiny package, one has to load the Shiny library, and we'll do that here in a moment. So you just use a library command and pass it the parameter Shiny, and what that does is allows the code, the actual R code that is the web application itself, to be run through one of two commands that we'll talk about in a moment. So I'm going to go ahead and load the Shiny library, which I've done here, and the web application itself, the R code for it sits in two files. One is a UI.R file, and the other is a server.R file. And again, these are just files on your system, or could be on the internet, for example in GitHub, and that's actually how we'll do it here today, which will make it available to any of you watching the video to be able to run this from your R using the code that I've written and uploaded to GitHub. The UI.R file, the purpose of that code is to set up what the web page actually looks like, and so it's the user interface part. And the server.R code really does the heavy lifting. It's the do the work part, and it populates the page. So all the analysis or the commands to generate the plots sit in the server.R file. And we'll go ahead and run the application I've put together, and then we'll go ahead and take a quick look at the source code for it, just to give a sense of how a web app using Shiny gets put together. So as I mentioned earlier, it can be run by accessing the UI.R and the server.R locally, or it can be, and to do that you use the command run app, and you pass it the directory where the UI.R files are located. So you can have as many web apps on your system as you like. Each one though has to sit in its own directory and contain both the UI.R and the server.R files. In this case, I've set up a variable in R that holds the directory where my UI.R and server R are located, so I could just pass it that file name. Or, like I said, it can be run from the internet, where the source code can be made public and anyone can run it. And that's what I've done with this application. It's stored on GIST or GIST in the GitHub.com web page. And the way you would run that is to use the command run GIST and pass it the ID number of the area that has the source code. And then for this app, that number is 9881583. And again, anyone can run this command from wherever you're at, and it'll run the web application. But you do need to load the Shiny library first in order for that to happen. So let's go ahead and take a look at this app, and I'm going to go ahead and do it from the internet available code. So we'll go ahead and do that. And from here, you can see that the web app is loading and now is on the screen. The app itself is set up so that you can have different areas on the screen. We've got a title here. We've got a left sidebar where the variables that you can enter are located. And then I've got the statistical, descriptive statistics also here on the left, so that they'll stay regardless of what we're looking for on the right. So we've got a normality test using Anderson-Darling. We've got the number of samples, standard deviation, variance, kurtosis, skewness. We've got the quartiles, and then 95% confidence intervals for the mean and median. And on the right, I've got this set up so that each of the different analysis are on different tabs. So we'll be able to just tab through and see those analysis. So we start off here with a histogram that goes along with the graphical summary, along with the distribution line that represents the distribution from this data. Now, just a quick note on this data. This data is invoice data from a process where a company was generating invoices, and the customers need the invoices generated and paid within 30 days, but the company didn't want to pay them any sooner than 10 days ahead of when they were due. So the spec limits that we'll see on the capability analysis in a moment are between 20 and 30 days. Alright, so clicking on the tab for box plot, you can see it pulls up box plot generated by R, and our median sits here around 26, as it says here in the descriptive stats, and we can read our box plot. Additionally, we can look at a control chart. Now, this control chart is one that's from the package QCC, and I've leveraged the control chart that's already been written. I didn't want to have to rewrite the code to do that. And as you can see, we've got the upper and lower control limits. We've got the center line at the mean. This process looks to be stable, looks to be under control, and also down here at the bottom does give you any points beyond the limits, or any violating runs of 7 or more above or below the center line. So from a Lean Six Sigma analysis perspective, this process looks to be under control. Next, taking a look at capability analysis. We can see here on the chart we've got our upper and lower spec limits, and some of the data sits in between. But in this case, we're spilling over on both sides of the control limits, and then we've also got within and overall distribution lines represented on the chart as well. And then we do have the statistics calculated. Shows the upper lower spec limits, the number of samples, the mean. We've got standard deviation calculated for within, which is a special calculation when the subgroup size is 1, and then regular standard deviation, and then CP, CPL, CPU, CPK calculated, as well as the overall. And in this case, they're pretty close because the standard deviations don't change much. And then finally, we can show the actual raw data from this variable by clicking the Show Data tab, and it just lists out the data as it exists in R. So that's the app. If I want to look at a different set of data, I can do that. I've got data from a project that looked at delivery times for a pizza shop, and I'll go ahead and type in this case, the data set has a data set name, and then a variable in that data set is baseline CT, and the spec limits were delivering pizzas between 20 and 45 minutes. And I can click on my update view, and it'll look now at this variable, update all the charts that we've looked at earlier, box plot, and graphical summary. So very easily put together using standard R functions, standard R graphing techniques, then as well as the functionality within the Shiny library to do the web app. So let's take a moment here and take a quick look at the UI.R and server.R code. But I do want to make one correction here from earlier, talking about the capability analysis. Clearly we don't have control limits on capability. Those are our spec limits. So I just wanted to make that correction real quick. So what we have here is the source code for the UI.R component of the web application. And what code we have here, we do have some libraries that we are including so that the statistical tests that we're running are covered. And then the shiny.ui really is just a function that has 3 pieces. And the first is the header panel, which was the title and name of the application. And then there's a piece here called sidebar panel, where we had all the input areas as well as the area where I had the descriptive stats. And you can see here there's objects called text input, numeric inputs, and then the submit button. And they're all named. These names will be referenced in the server.r code so that it knows what to act on. And then the main panel is set up with a header of its own, and then this command tab set panel, which sets up each of those folders or each of those tabs. And again, you can see here they're titled graph summary, box plot, control chart, capability analysis, and show data. And each one has a name, again, that'll get referenced in the server.r code. And really that's it for the UI.R. Really, again, just sets up how the page looks and names, gives variable names to each of the components of the page. The server.r routine also includes the library calls. This is just to ensure that the libraries that are needed are loaded. And then the main function call here is Shiny Server, and there's 2 things. There's inputs and outputs, which relate to those objects that were listed in the UI.R. Here I've actually embedded the invoice data that we used as a sample so that anyone who accesses this web app has availability to the invoice data. And then each of these subroutines that are listed here now actually do the work to populate each of those objects on the main parts of the screen that are set up in the UI.R. So for example, the output $stats, render print. This is the descriptive stats that were in the sidebar, and here it just calls a function that says what's the name of the data set from the input that was given, and then it cats out the text for all the descriptive stats, and then over here each of the functions that provide those statistical analysis are called and also put together to be printed. And really that's the basic concept of how the server.r works. Each different tab and each different section has its own function call. Here's the code that actually generates the histogram and the graphical summary, and the histogram plot, as well as the distribution line there. So I don't really want to go into too much more detail other than just to give that sort of high level concept that the UI.R sets up what the page looks like, and the server.R here has all the code that generates the information that gets showed in the app itself. So I'm going to wrap this video up here at this point. I hope this gave you a good overview of how the web apps can be written in R using the Shiny library, how R can be used to do the analysis for the measure phase of a Lean Six Sigma project, and does incorporate the code that I've used in my project for class. So thanks for tuning in, and we'll be posting additional videos soon, so please come back and visit the R for Lean Six Sigma channel often.